Okay, just dealing with a couple of queries. I was asked about identities. It's triple equal sign. Now, the difference between an identity and an equal sign is an identity shows that two things are algebraically equivalent. For example, 2x plus 3 equals 13. That's an equation that we can solve. Take away 3 from both sides. 2x equals 10. Divide both sides by 2x equals 5. So the original statement is true for the value x equals 5. Now, an identity, on the other hand, shows that two things are equivalent for any value of x. So, for example, 2x plus x is always equal to 3x, no matter what the value of x is. So it's showing that two things are not only equal for a specific value, but equivalent, always equal for all values. Okay, I was asked about this question with an operation denoted by an upside down sort of triangle thing. Now, this isn't a standard part of mathematics. This is just something that's been invented for the purposes of this question to see how well you can deal with the way this is defined. So A triangle B means 2a squared minus 7a minus b plus b squared. So x triangle 3 would mean, let's just write this down, x triangle 3 would mean, so wherever an a is here, I'm going to have an x, and wherever b is here, I'm going to have a 3. So x triangle 3 would mean 2x squared minus 7x minus, instead of b, 3, and instead of b squared, 3 squared, which would be 9. So x triangle 3 means 2x squared minus 7x minus 3 plus 9, which is the same as 2x squared minus 7x plus 6. And we are asked to work out all of the solutions of the equation x triangle 3 equals 0. So in other words, we need to solve 2x squared minus 7x plus 6 equals 0. And that you can do, well, there'll be two solutions to that possibly. A maximum of two solutions. Maybe there won't be any, maybe there'll only be one. But being a quadratic, there'll be a maximum of two solutions, and you can solve that using the quadratic formula. X equals minus b plus or minus square root b squared minus 4ac all over 2a, with a, b, and c being 2, minus 7, and 6. You can probably figure out the rest of that yourself. Okay, then I was asked about this question. In the diagram, points A, B, and C lie on this straight line, which is 2x plus y equals 3. Now I'm going to rearrange that in the more recognizable form by taking 2x away from both sides. So that's the same as y equals minus 2x plus 6. Writing it in that form tells us more about the curve, the line rather. The plus 6 on the end tells us that it cuts at 6, and the minus 2x tells us the gradient. It means for every 1 across, it goes 2 down. It says B is the midpoint of AC. Okay. Well, at A, y is 0 because it's on the x-axis, so the y value is 0. So at A, if the general equation of the line is y equals minus 2x plus 6, and y is 0 here, we can find out what x is by putting y equal to 0 in there. So 0 equals minus 2x plus 6, 2x equals 6, x equals 3 here. So A is the point 3, 0. And if B is the midpoint of A and C, and B is in the middle of the axes and goes and meets A at 3 from the axis, x equals 3, then C must be when x equals minus 3. So C is at minus 3. And D is the point minus 7, 0, it says. Okay. We can work out the coordinates of C. Because we know that x is minus 3. And that it's on the line y equals minus 2x plus 6. So y equals minus 2x plus 6. We know at this point that x is minus 3. So y equals minus 2 times 3, which makes plus 6. And then plus 6 on the end. So y is 12 at that point. So the coordinates of C are minus 3, 12. So obviously I need to set that out, well, write all of this stuff that I've written up here neatly down here, but let's take that as read, that in an exam situation I would have done that more neatly down here. So far we've established that A is the point 3, 0, and C is the point minus 3, 12, and then we're told that D is the point minus 7, 0. Now we can work out the gradient between C and D by working out the change in y over the change in x. So the gradient of line CD, or DC, is the change in y, 12 minus 0, over the change in x, minus 3 minus 7. Minus 3 minus 7. So that's 12 over minus 3 plus 7 is 4, which is 3. So the gradient of that line is 3. So in other words, for every 1 across, it goes 3 up. Now, the equation of the line through C and D is always going to be in the form y equals something x plus something. And the something in front of x is the gradient, which is 3. So the equation of line CD is y equals 3x plus something that we've got to establish. We can find out what C is because we know for a particular point what y and x are. For example, at the point D, we know that x is minus 7 and y is 0. So at D, 0 equals 3 times x minus 21 plus C. So that tells us that C must be 21. So the equation of the line is y equals 3x plus 21. And although these things aren't drawn accurately, it does look reasonable in terms of the sketch because it cuts higher up than the other line, and it has got a positive upward gradient. So y equals 3x plus 21, common sense tells us, is a reasonable enough answer.